In this exercise, we're going to talk about Unix file access control list. Take a look at this file.txt. If you do ls-l on file.txt, it will give you the result as the permission, the root on this file, and the root group on this file. And currently this file is 0 byte, and the timestamp the file was last accessed or created. Now the first character tells us that this is a regular file because it is a dash. The next 9 characters tell us the permission of the file. RWX, which R stands for read, W stands for write, and X stands for execute. Now the first 3 permission denotes the owner permission. In this case, the owner root has read, write, execute permission, which is RWX. And the next 3 again is RWX, which is denote the group permission. Again, group has read, write, execute permission. Lastly, the last group of RWX represent others permission. In this case, others also has read, write, execute permission to the file.txt. We can take a look at the permission of a directory called some_dir. Notice the first character now is a D to denote that this is a directory that we are looking at. And the first 3 permission is RWX, which denote the owner permission is read, write, execute. The next 3 R-X denote the group permission. Again, the group has only read and execute permission. In this case, for directory, X means accessible, and others also has read and accessible permission for some_dir directory. As you can see, only the owner has write permission to the directory, as denoted by RWX for the owner permission, where the groups and the others, though they can read and access the directory, but they cannot write into the directory because the W is missing and replaced by a dash. So as we have previously stated, Unix has 3 categories of permission: user, group, and others. And they are denoted by RWX, which R stands for read, W stands for write, X stands for executable. Now the octal permission for read is 4, W is 2, and X is 1. Same for the rest. Let's see how we derive R equal to 4, or write equal to 2, and X equal to 1. If we change this to symbolic permission, you get R dash dash. The binary is 1 0 0, dash dash is 0 0. Only the read bit is set, so you get binary 1 0 0. If you convert binary 1 0 0 to octal, you get 4. Similarly, for write only, you only have the W bit set, so you get 0 1 0. 0 denote the dash. So if you convert the binary to octal, you get 2. And lastly, for executable only, which is dash dash X, the binary is 0 0 1. And if you convert that to octal, you get value of 1. So remember, read is 4, write is 2, and executable is 1. Take a look at this example where user has read, write, but no execute permission, so with dash, and group has only write permission, and others has read permission. So if you convert them to octal value, what will it be? For R equal to 4, W equal to 2, so you can take 4 plus 2, which equals 6. Group W is equal to 2, and the rest is 0, so you plus them together, you get the value of 2. Others only has a read permission set, so it's equal to 4. So when we do chmod, which is changing the permission, and 624 on file.txt, is the resultant permission will be rw dash dash w dash and r dash dash. Let's do that by doing chmod 624 on file.txt, and we do ls -l on file.txt. You notice 624 will produce the permission rw dash for owner, dash w dash for group, and r dash dash for others. Now, instead of symbolic permission, if you are given the octal permission, in this example 532, you can also derive the symbolic permission. So in this case, 5, user has a permission octal value of 5, which is derived from 4 plus 1, which is read and execute permission. So 5 is equivalent to read and execute permission. For group, the octal value of 3 can be derived from 2 plus 1. So write is set and execute is set. So it's a dash wx for group permission. For others, it's a value of 2, which is write. So you get a dash w dash. chmod also can change the file permission using the symbolic way instead of using octal value. So I can do chmod u equal to rx, which say user permission has read and execute permission. G is group, which is equal to write and execute. O is others, which is equal to write for the file.txt. So if we do ls -l on file.txt again, you can see that the user has read and execute permission but no write. The group has write and execute permission but no read, and others have write permission but no read or execute permission for file.txt. So as you can see, using chmod, you can use either the octal permission to change the file permission, or using the symbolic way to change the file permission. In the last example here, you saw chmod a plus r on file.txt. This will set the user, group, and others to have read permission. Similarly, if you do a minus r, the user, group, and others permission will take away the read permission. This ends the demo.